Okay, this recording is for the 1-act kids. Everybody say hi, 1-act kids.
Hi, Brendan. Hi, Brendan.
Okay, that was unnecessary, Kate.
Hi, Brendan.
All right.
Hi, Dakota.
Okay.
All right. Katie. Okay. Hi, Katie.
Hi, Brendan.
Hi, Caleb.
All right, be quiet. Infinite limits. Definition of an infinite limit. Okay. Infinite limits will happen when? Where vertical asymptotes are. That's what will happen. Where you have vase, you will have infinite limits, and that is all. Where you have holes, you will have actual numerical limits. You'll have actual numbers that it's approaching, right? Because it's just a hole in the graph. But if you have a vase, he's going to, like, on one side of your graph, like, either shoot up or shoot down forever and ever and ever and ever and ever, according to where that vase is located. Okay? So, down here, I'm going to get back to the note here for just a second, but if we were to say, like, let's say this is the graph of 1 over x squared. Okay, 1 over x squared looks very similar to that guy. Okay, the graph of 1 over x squared. And let's say I'm trying to find the limit as x goes to 0 from the right, and the limit as x goes to 0 from the left. Okay, of 1 over x squared of 1 over x squared. And let's say 0 lives here. This is where 0 is. Okay? So I'm trying to find the limit as it goes from the right. This guy means right. This guy means left. Okay? So as he's coming in from the right, as he gets closer and closer to 0, he's going up and up and up and up and up and up and up forever. So what do we call that limit? Infinity. That limit is infinity. Okay? Now, if we're coming in from the left, it's going up and up and up and up and up and up and up forever. So what's that limit approaching? Also infinity. Okay, so if I were to say I want to find just the limit as x goes to 0 in general, both sides together, of 1 over x squared, what is it approaching both sides together, 1 over x squared? Infinity, right? These are both consistent with one another, so it is approaching infinity. Now, you want to know what my book says as an answer? They do not call that limit infinity. They say that the limit does not exist because infinity doesn't really exist. There's not a number that infinity is, right?
40.
Okay, I will take either one. If you want to say does not exist or you want to say infinity, I am fine with that, right? I am fine with that. A lot of times I will say infinity just because that's what he's approaching on either side, right? I won't put does not exist, but keep in mind, this is what the note says. This does not mean that the limit exists. In fact, the limit does not exist. There's not one limit that it's approaching. It's not a number that it's approaching. It just tells you how the limit fails to exist. Okay? So the limit does not exist because it's approaching infinity on both sides. Does that make sense? Okay. All right, so let's look at some of the other examples. They have this one right here. This is 1 over x plus 1 or x minus 1. So I'm going to do limit as x approaches, where's the vertical asymptote at?
1.
1. Okay, so we're going to look at 1 as he approaches 1 from the plus, and the limit as x approaches 1 from the minus. Of 1 over x minus 1, of 1 over x minus 1. We're going to figure out what each one of those is. Okay, so 1 from the plus means from the right. So as he's coming in from the right side of 1, what's he going toward? He's going toward infinity. He's going up and up and up and up and up forever, right? Okay, what about from the left side? He's approaching, he's going down and down and down and down and down. So he is actually approaching negative infinity. Okay? So if I were to ask you what the limit is just as he's going toward 1, would you, from both sides together, would you put infinity or would you put negative infinity? This one has to be does not exist. Has to be does not exist. Because they have conflicting behavior. Those are not the same thing. So this one has to be does not exist. Does that make sense? They are going opposite directions, so that is definitely does not exist. This is the exact example of what the Mean Girls one was. Right? They're going opposite directions, so the limit does not exist. Okay? All right, we kind of did this one already, this middle one, so let's go, I don't know. Let's go to like this last one. So limit as x goes to the vertical asymptote there is at 1 also. So we're going to go run from the right We're going to go 1 from the left. Okay? And I'm going to be lazy and not write f of x because I'm running out of space. Okay? So normally you have to have your function in here. So f of x goes here. And f of x goes here. But I'm running out of room. So I'm just going to put limit. Okay? So as he's approaching -1 from the right side, what's he doing? He's going negative infinity. He's coming in from the right side. He's going down, 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 down. Negative infinity. Okay? Coming in from the left side, he's going down, 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 down. Negative infinity. So, from both sides in general, there are two, not from 1 minus, just 1 in general. What would you put? You can either put negative infinity or you could put does not exist because negative infinity technically is not a limit. It just does not exist. Does that make sense? We're going to talk about that as well. We will talk about that, like, maybe in this chapter. I don't know. Maybe not in this chapter. Yeah, we'll see. Okay, vertical asymptotes. Determine all vertical asymptotes of the graph. This guy right here, where is his vertical asymptote located? How do you know that for sure, that it's at -1? Well, kind of, yeah. Judging from the equation, how do you know that there's a bar there?
1.
If you look at the bottom, the x plus 1 can't be 0. So, x can't be -1. That's where the vol lives, right? It's like where you find domain. So, it's another way of looking at it that way. And then that's where we're going to find the limit at. Okay? We're going to look at behavior on either side because I cannot evaluate at -1. That's why we choose to look at limits at those places because funny business is happening at -1. So we choose to look at the behavior on either side to see what is happening there. Okay? All right, next one. What's the va there? No. Which is what? So x equals 1 and x equals -1. There are two vas there. -1. There are two vas right here at 1, right here at -1 because x squared minus 1 can't be 0. X squared can't be 1. And x can't be the square root of 1, which is plus or minus 1. Okay, that's where we get that from. Okay, so just remember, that's where it comes from. What about 3? What's the va there? The va is at x equals 2. It's hard to tell from the graph that that's actually at 2, but if you look at the units, it makes sense. Because x minus 2 can't be 0. So x can't be 2. Okay, good? Good. All right, go to the middle. Middle page. Okay, next. All right, this one. Determine all vertical asymptotes of the graph. Of this thing. Be very careful. Listen. Be very careful. Vertical asymptotes come from the bottom. But if it's a factor of the bottom, doesn't necessarily mean it's a va. What could it be instead? No. It could be a whole. Could be a whole instead. Okay? So let's do the top and the bottom. So x squared plus 2x minus 8. Let's factor the top. How does he factor? X plus 4, x minus 2. Okay, what about the bottom? X squared minus 4. That is a difference of squares, right? So plus 2 minus 2. Okay? All right, so according to this, I should probably have a va at 2 and -2. But this one is actually a whole. So the only va that I have is x equals what? -2 because I have to set this equal to 0, right? So the whole exists at +2. This is a whole. And you can see that from the graph. The whole is here, the va is here. Okay, so be careful. Just because he factors from the bottom doesn't necessarily mean he is a va.
So the whole is at 2 because...
The whole is at 2 because that's the part that crossed out, right? And x minus 2 really means x equals 2. That makes sense? Yep, the whole is at x equals 2. Good? All right. Determining limits. Determining limits.
Because her ornaments, her balls, are compared to no question was.
Okay. Whatever. We don't care. We don't care. Be quiet.
You don't care about that theorem?
What theorem? Did I skip one? No, this is the theorem. Yeah.
Oh, no.
I put the theorem up there. We're going to talk about it. Okay. So, in this one, let's say you have a function where the limit is infinity. Like, let's say I'm trying to find the limit as x goes to 0 of 1 over x squared. What does 1 over x squared look like again? It looks like a boomerangs, but both of them go up. Okay. So as I'm coming in towards 0, both sides are going toward infinity, right? So this one has a limit that goes toward infinity. Yeah. Good. Yes, infinity. This one is infinity. Okay. And let's say instead I also have something else, right? Let's say I have the limit as x goes to, let's say, 3 of x, right? What does x look like when you graph him? It looks like a line, right? Y equals x is that line. So, how do I figure out his limit? What's the limit as x goes to 3 of x? How do you get 3? You just plug 3 in for x. See, those are the ones that are going to get you. I warned you about that. Plug it in, right? 3 plugged into x. 3 plugged into x is just 3. Just 3. So I have an infinite limit, and then I have a limit that actually exists. So I have those two things going on, okay? Now, if I'm adding or subtracting, okay? If I'm adding or subtracting, and I take those two functions and add them together, I'm going to do this over here. If I would now say, let's find the limit as x goes to, oh poop, they should have had the same thing. Shoot. I wanted them to have the same number. Okay, I'm going to change this just a little bit. Let's say x plus 3, and we'll make him go to 0. Okay, I'm going to change that just a little bit, and I'll show you why. I want the limits to both go to 0, right? Limit as x goes to 0 for both of them. So I'll just change that to be x plus 3, and then you're still plugging them in, and you still get 3, okay? So, now I want the limit as x goes to 0 of, I want to add them together, 1 over x squared plus x plus 3, right? This is what I want to find the limit of, that whole big thing. How do I find the limit of that? How is it 3? I changed it. I'm going to say as the limit goes to 0 of x plus 3. So I plug it in, so it's still 3. So it's still 3. She's doing it, okay? I just changed it so that both of them are going to 0. Okay? Otherwise it's not going to. So the limit is x goes to 0 of 1 over x and then x plus 3. Okay, so I can look at those individually. So what was the limit as x goes to 0 of 1 over x? This guy was infinity. And what was the limit as x goes to x plus 3 when I'm going to 0? Or whatever. This was 3. If I take infinity and add 3 to it, it's happening, Kate. If I take infinity and add 3 to it, does it really matter? It's still infinity.
That's big numbers.
Okay?
Like, all those times like you...
So it's still going to be infinity. Now, let's say I was subtracting those. Let's say I had infinity minus 3.
It's still the same thing. So first, the same thing first, 1.
Oh my.
So
Okay.
You're all wrong.
So that's what this rule right here says. If I take f of x, listen. Shh. If I take f of x and I add it to g of x, it's infinity. Right? Because infinity plus 3 is still a really big number. What happens if that was minus instead? Like infinity minus 3. It's still going to be the same thing. It's still going to be a really big number, right? If I'm subtracting 3 from a really large number, it's still going to be a really large number, right? Okay? Same thing. Okay? Now, if I am multiplying one by the other, right? Okay, this would be like 3 times infinity. What would 3 times infinity be? This is product. 3 times infinity is still going to be a really big number, so it doesn't matter, right? Now, here's my question to you. They say infinity or negative infinity. That just depends on whether your constant is positive or negative. So if it was negative 3 times infinity, it would be negative infinity, right? Does that make sense? Okay. Let's go to the last one. This one's going to blow your mind. Okay, Kate? This one's going to blow your mind. Quotient. When you're doing quotient. Quotient is when you're dividing them. 3 divided by infinity, okay? Now, 3 divided by infinity. Let's think about what this looks like, okay? Let's say infinity is just the number 10, right? 3 divided by 10 is 0.3, right? Infinity is not, like 10 is not a really big number, but we're going to go toward that, okay? Okay, so let's say that instead of 10, my infinity is 100, right? That would be 0.03. Okay, let's say instead of it being 100, it's 1,000. And that's 0.003. Okay, so if I'm taking a constant and I'm dividing by a large number, the larger that number gets, the closer that number gets to.
What if you take infinity divided by
You're not listening to me. Okay, I'll restate. If I take a constant and I divide by infinity, as that number gets larger and larger, like 10 goes to 100, 100 goes to 1,000, 1,000 goes to 1,000,000, whatever. What does that number, 0.3, 0.03, 0.003, what number does that get closest to? 0, right? So if you have a constant divided by infinity, it's going to get closer to 0. That's what this thing is saying right here. If you have a quotient where g of x is the constant, this is just a number, and this is infinity, it's going to be 0.
I have a good question.
What was your question?
What if you take infinity divided by 3?
We'll talk about that. That's something you cannot do. Then we have to
It's
change what he looks
illegal.
like. That's what we have to change what he looks like.
We'll call the cops and say 420.
That's called an indeterminate form. We'll talk about that in here in a minute.
You just
You just wait a minute, boy. You're asking all these questions, and then we do them like 30 seconds later, right? You just asked me, like, what if you take infinity and subtract a number? I'm like, just wait a minute, because that's what we're going to do, right?
That's crazy.
Oh, that's crazy. That's crazy.
Let's look at the
Okay.
lesson in this question.
Okay? So we'll do 1 and 2 and then we'll quit, maybe.
Okay.
Yeah, sure. Why not? We'll do 1 and 2 and then we'll quit. So as x goes towards 0 of 1 and as x goes towards 0 of 1 over x squared. So I'm going to separate these two pieces. So let's do this. I'm just going to look at the limit as x goes to 0 of 1. And I'm going to look at the limit as x goes to 0 of 1 over x squared. So if I'm looking at the limit as x goes to 0 of 1, what is that going to be as a limit?
0.
1.
You just plug it in, right? I can't plug 0 in anywhere, so it's just going to be 1. This is the one where you have, like, what does this guy mean? Y equals 1. What does he look like? He is right here at 1. And if I'm trying to figure out where he's going towards 0, as he's coming in from the right and as he's coming in from the left, he's approaching a y coordinate of 1, right? That's what he's doing, okay? So the limit as x goes to 0 of 1 is just 1. It's just the constant, right? Okay, what's the limit as x goes to 0 of 1 over x squared? Infinity. Okay, so what's the overall limit? Infinity. It doesn't matter that that 1 is there because 1 plus infinity is still a really big number. So there's that. Does that make sense? Yeah? Okay. Second one. Oh my. Oh my. Oh my. Okay. So let's do this. Let's do the top. So I'm gonna break this down into 2 different pieces. Let's do the limit as x approaches 1 minus of x squared plus 1. And let's do the limit as, this one's a little harder, 1 minus of 1 over x minus 1. Okay? And we're going to work each one, the top and the bottom, individually, right? Top and bottom individually. Okay? On the top, the limit as x goes to 1 of x squared plus 1. Forget that that minus is there, right? Can you just plug that in?
Yeah.
On the top? Yeah, you can just plug 1 in on the top. So I'm going to plug 1 here. Doesn't matter that it's minus. Doesn't matter that it's minus. I can still plug it in, right? So I plug 1 in there. 1 squared plus 1 is 2. So I have 2 on the top. divided by. Okay, do you know what 1 over x minus 1 looks like? Do you know what 1 over x looks like? What's 1 over x look like? He's a boomerang. Okay, but what does the minus 1 do to him?
Down one.
Nope, not down one.
Right one.
It moves him to the right one. Okay, so he's going to be to the right one like this. Right? Okay, so that's what he looks like. All right, now I'm looking at approaching 1 from the left. I'm looking at approaching 1 from the left. So I'm coming in from the left side, coming in from the left side. Where's he going? He's going toward negative infinity, right? He's coming in from the left, coming in from the left, coming in from the left, and he's going down, 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 down. So negative infinity, okay? So we just kind of touched on this one. What's 2 divided by a really, really big, actually this one's a really, really small number.
Negative.
It's a really, really big negative number.
You can't do it. You can't, does not exist. Hey, what?
No, it's not.
You said
No, I said infinity divided by a different number.
No, he said infinity on the top. Okay? So what does this do? What is 2 divided by negative infinity? Okay, well, let's do this. Let's do this. Think about it this way. 2 divided by infinity with a negative out in front of it that way. It's negative 0.
0.
So it's 0.
So smart.
Oh, shoot. So it's still 0. It's still 0. It's just negative 0, which is like 0. And what that means is that it's approaching 0 from the underside. When it's negative 0, it's approaching 0 from the underside. For
So every time you divide, you just put 0.
divided by infinity? Like a constant divided by infinity? Yes, it's 0.
Unless infinity's on top.
Unless infinity's on top, then we're gonna do that later. Okay, so I'm gonna wait and we'll do the rest of this tomorrow. Okay? All right, we'll do the rest of that tomorrow.
What is that?